right, guys, I'm going to get started. First, let me start with a couple announcements. Tomorrow is PSATs. So there are some students who are taking the PSATs and there are some students who are not. So because of that, and the fact that they're using our classroom as one of the testing rooms, tomorrow's going to be a little chaotic. So I have chosen not to make you guys Google Meet tomorrow, and I have not, we will not be assigning any new work or anything like that for tomorrow. We'll just pick back up on Wednesday because I don't want the students who are taking the PSATs to miss anything, and I don't want anybody to be in a different spot. All right, so we'll just pick back up on Wednesday. All right, so if you are coming into school tomorrow and you're not taking the PSATs, then we will not be in our normal classroom because they're using our classroom. You have to go to room D06. I put it on Google Classroom just so you could see it in writing, but just know that my Tuesday kids, if you're coming into school tomorrow and you're not taking the PSATs, we will not be in our classroom. We will be in room D06, okay? All right, so remember, otherwise, the homework that I assign you guys today isn't going to be due until tomorrow night at 11:45 like usual, and that's all you'll have for today and tomorrow is the 10-question homework that I assigned for you guys, okay? Did I miss something in the chat?
Mine's not loaded.
Okay. Okay. All right, so I just wanted to get that out of the way so I don't forget to remind everybody, all right? All right, so guys, I gave you kind of off on Friday because before we started the new section, now that we were kind of done with the graphing of the parabolas, and I said we would start the next section today on Monday. So the next section is section 4.3. We skipped 4.2, and it's on how to solve a quadratic equation by factoring.
Jackie raised her hand.
Oh.
She did it on purpose.
Go ahead, Jack. You got a question?
She may have just had enough by accident. That was the ding we heard.
Oh, okay. All right. So again, when we go to solve a quadratic equation by factoring, it's one of the various methods that you learn how to solve a quadratic equation by. So before we actually solve the quadratic equations, I actually wanted to review a few things with you guys first so you can kind of understand what it is you're finding and how you're finding it, okay? So coming off of the graphing of the parabola, we found some pretty important points on the graph of the parabola. We found the vertex, we found the y-intercept, we found the x-intercepts, and whatnot. So I wanted to review with you guys what those points are so that maybe when we go to solve a quadratic equation, you'll understand what we're finding a little bit better, okay? All right, so the y-intercept, right? It's the point on a graph where the graph crosses over the y-axis. It's always some point 0, y. If you're going to be directly on the y-axis, then you have to have an x-coordinate of 0, right? All right, the graph of a quadratic equation, which is a parabola, guys, it's only going to have one y-intercept. A parabola will only cross the y-axis one time. Okay, when graphing a parabola, if we did not see the y-intercept on the graph, then we would find it ourselves by plugging 0 in for x and seeing what came out as y. Remember doing that? If we didn't see the y-intercept, then we would plug 0 in for x and find out what y was. Because we know the x-coordinate of a y-intercept has to be 0. So go to the equation. Here's a quadratic equation whose graph is shown, and we do not see the y-intercept. So if we were going to find this ourselves, we would plug 0 in for the x's, and we would see what number came out for y. And then that y value would be the y-intercept. That's what we did. Remember doing that? Thumbs up if you guys remember doing that. That's how we found the y-intercept ourselves. Okay, well, some other important points that we saw on the parabola were the x-intercepts. And these are the points where the graph crosses the x-axis. Let me move this up before I get talking too much. Did something else happen there?
Yeah, some of these things. Hold on. I lost it. I don't Oh, no worries, Angel. Angel's having internet issues.
Okay.
I don't think he can hear me, but.
Okay. All right, so the x-intercept, right? We would want to find the x-intercepts of our parabola. Those are the point or points where the graph crosses the x-axis. Since you are directly on the x-axis, you're the point x0. Your y-coordinate has to be 0 in order to be an x-intercept. The graph of a quadratic equation, a parabola, will have 2 x-intercepts, 1 x-intercept, or no x-intercepts. Remember, here's a parabola with 2. Here's a parabola with 2 x-intercepts. Here's a parabola, and here's a parabola that only have 1 x-intercept. Here's a parabola that has no x-intercepts, and here's a parabola that has no x-intercepts. So the x-intercepts are always a little bit more complicated because there could be 2, there could be 1, or there could be none. Where the y-intercept was so simple. There was only 1, and all we had to do was plug in 0 for x to find it. Well, here, when we were using parabolas, when we were graphing a parabola, if we did not see the x-intercepts on the graph, then we would make an educated guess or estimate as to where it looked like the parabola was going to cross the x-axis. Remember doing that? All right. So guys, here's a quadratic equation that I graphed. It looks like the parabola is crossing the x-axis between 0 and 1, so we would guess. And it was in between -2 and -3, so we would guess. The reason I had you guys guessing and not solving for it is because if we were going to solve for the x-intercepts, we'd have to find x when y is 0, which means you basically have to set the equation equal to 0 and solve. But I have not taught you how to solve this equation for x yet. You have not seen how to solve a quadratic equation yet. That's why I couldn't ask you guys to solve for the x-intercepts like I did the y-intercept, because you don't know how to solve this equation yet. So this section, 4.3, is all about learning how to solve this equation. How do we set a quadratic equation equal to 0 and solve for x? How do I find its real x-intercepts so that I don't have to guess as to where they are? All right? That's what the point of today's section is. So, in order to solve this quadratic equation for x and find those x-intercepts, we need to know how to solve a quadratic equation. One way to solve a quadratic equation is by factoring, which I do believe you have seen in Algebra 1. All right? Factoring is a very important algebra skill that is used in many upper-level math classes. Guys, this is a skill that once you learn it, it never goes away. It's going to pop up in every math class from here on out. If you go to college and take math, factoring will be in it. If you are going to take a math placement test to get into your college, which you probably will, factoring will be one of the topics on that placement test. It is a very important skill. So I always say to my Algebra 2 students, if you're going to let me teach you anything this entire year, please let it be factoring. Let me teach you how to factor because it's something you're going to use over and over and over again, okay? All right. However, before I teach you guys how to factor, I want to review something with you. Do you guys remember how to FOIL? First, outside, inside, and last. Factoring is literally undoing a FOIL. So if you remember how to FOIL, factoring sometimes can be a little bit easier because you're really just undoing a FOIL when you factor something. So today, I don't even want to show you factoring yet. I want to review what foiling looks like so that when I teach you how to factor on Wednesday, this might look a little bit easier, okay? So all we're going to do today is review FOIL. And all FOIL was a way to multiply two pieces with two pieces. Two-term polynomial with a two-term polynomial, okay? All right, so that's what we're going to do. We're going to review FOIL today. All right, so I know it's called FOIL, but I'm telling you, I don't even think of it as FOIL. If I want to simplify the following expressions, well, guys, they want me to take this parenthesis and multiply it because they're attached with this parenthesis. Well, PEMDAS would tell us to do inside parentheses first, but I can't take an x and add it with a 3, and I can't take an x and add it with a 5, so I can't do inside the parentheses. So how am I going to multiply all this together and get rid of these parentheses? Well, guys, if you think about it, if it was just 3 out in front, all you would do is distribute the 3 and be rid of the parentheses. But because you have two pieces, I think of it as double distribution. Take the first term in the first parentheses, distribute it to everything in the second parenthesis. Once you've multiplied x with everything over here, then take the next term, positive 3, and distribute it to everything in the second parenthesis. And that's basically what FOIL is. Take everything in this parenthesis and distribute it to everything in this parenthesis. All right, ready? Let's give it a go. So FOIL says to do first, outside, inside, and last. I just think of it as double distribution. So first we're going to do x times x. Anybody know what x times x is? Think about what it is when you times something by itself twice. 2 times 2 is 2 squared. 3 times 3 is 3 squared. So x times x is x squared. A lot of students want to put 2x, but guys, that would be x plus x. X times x is x squared. All right, then you take x and you distribute him to the next term. So x times positive 5 is positive 5x. So you see how you've taken x and you've multiplied him with everything over here? That means you're done with x. Now take the positive 3 and distribute him to everything in the next parenthesis. So positive 3 times x is positive 3x. Positive 3 times 5 is positive 15. And then normally with a FOIL, your middle terms are like terms, so we combine them. So x squared plus 5x plus 3x is 8x, and then plus 15. Okay, so what does this have to do with factoring, right? Well, here's the deal. In the future, you're going to be given a quadratic equation that you're going to set equal to 0 and solve, right? We're going to find x when y is 0. We're going to find the x-intercepts. One way to do that, one way to solve this equation is to factor it. Break it up into pieces that multiply to equal. Well, who multiplies to equal this? That. You would factor it into his original parentheses, x plus 3x plus 5. And then there's a solving process from there. But that's what we're going to be doing. We're going to be taking a quadratic equation and we're going to break it back into the two pieces that multiply to equal it. That's factoring. Factoring means to break things up into pieces that multiply. So you're going to be given this and we're going to have to find what were those two parentheses that multiplied to equal him. So you have to undo that FOIL in order to factor. All right, that's going to come though. Right now we're just reviewing FOIL. All right, let's do this one. Let's FOIL this, right? Let's multiply these two pieces together. So like I said, it's just double distribution. First, we're going to distribute x, then we're going to distribute -4. All right, so x times x is x squared. X times positive 9 is positive 9x. -4 times x is -4x. And then -4 times positive 9 is -36. And then we just combine like terms in the middle, and we're good to go. So x squared, 9x, take away 4x is 5x, and then -36 comes down. So again, if I wanted to find the x-intercepts on the graph of this quadratic equation, I would set it equal to 0, right? And I would factor this so I could solve for x, and it would factor into these two parentheses. These are the pieces that multiply to equal it. So factoring it is just going to be undoing the FOIL. Do you guys remember this a little bit from Algebra 1? Okay. Like I said, I'm just trying to make sure it all ties in, that you are finding the x-intercepts when you do this. All right, here we go. Let's try this one. So if I multiply this together, right? 3x times 1x is 3x squared. 3x times -7 is -21x. -1 times x is -1x, or -x. And then -1 times -7 is +7. Combine your middle terms, and you end up with 3x squared. That'll get me -22x's, and then +7. So again, in the future, if I want to solve this quadratic equation for x, for the x-intercepts of his graph, I'm going to set it equal to 0, and I'm going to factor it into the two pieces that multiply to equal it. So that's where we're going to be going. We're going to be given these, and we have to get here. We have to undo the FOIL to factor it. Okay? All right, I put a star next to this one because I want to show you something with this one. All right, let's FOIL it out. Let's see what we get. So 2x times 2x is 4x squared. 2x times -1 is -2x. 5x times 2x is +10x. And then +5 times -1 is -5. Combine your middle terms, your like terms, and you end up with 4x squared plus 8x minus 5. So guys, in the future, if I wanted to find the x-intercepts of his graph, right, if I wanted to solve this quadratic equation, I would set it equal to 0, which I started because, guys, look at this equation. It's the same equation we started with. It's the same equation that I gave you the graph to on the front of your notes, whose x-intercepts we were going to have to guess. One of them was in between 0 and 1, and the other one was in between -2 and -3 on the graph at the top of your notes there. All right? So if I wanted to set this equation equal to 0 and find his x-intercepts by hand so I don't have to guess, I would take this equation, I would factor it, I would break it up into the pieces that multiply to equal it. So in this case, it would be 2x plus 5 and 2x minus 1, right? Now I'm getting a little ahead of myself. I'm just trying to show you how this is all going to tie in. Then to solve an equation by factoring, you take each one of these pieces, 2x plus 5, set it equal to 0, and solve for x. Watch what we get. Minus 5, divide by 2, and you find out that x is -5 divided by 2 is -2.5. Take the other piece, take the other factor, if you will, 2x minus 1, set that equal to 0 and solve. Add 1, divide by 2, and you find out that x equals 0.5. So guys, what you have just found is you have found the x-intercepts of that quadratic equation. You have found the points where his graph will cross over the x-axis. Now watch, when I go back, -2.5 and 0.5. Look at the graph. So before, we had to take a guess. Where was the graph crossing? Somewhere in between 0 and 1. Well, guess what? That's the 0.5. That's 0.5. That's his x-intercept. And then we said somewhere in between -2 and -3. That's the -2.5. So when you take a quadratic equation and you set it equal to 0 and you solve by factoring, you are finding those x-intercepts. Before, I hadn't showed you how to do that yet, so I couldn't ask you to do it. I had to ask you to make a guess. Now, you're going to know how to do it. You're going to factor this quadratic, and you're going to set those factors equal to 0, and you'll be able to solve for those x-intercepts. So that's what you're finding. When you're taking these quadratics and you're factoring them, and you're taking these factors and setting them equal to 0, that's what you're finding. You're finding this parabola's x-intercepts. Does that make sense? Yeah? Everybody okay with that? Okay. All right, you guys do the last example, and then I'll match it, and then you guys are going to be done. Is you okay?
Yeah, he just hit the keyboard back.
Okay.
That's a lot of plus sign.
Okay. All right, try the last one, and then I'll give you a little bit of a head start, and then we'll match our answer. You guys good? Are we okay? Okay, guys, everybody match your answer with mine. Everybody good? Thumbs up? Okay, so again, I didn't want to go right to the factoring without reviewing the foiling. So that's why we do this. I hope it's easy. I hope you guys all remember how to foil, and that it'll make factoring just that much easier when we start it on Wednesday, okay? All right, so guys, you have homework on Delta Math on the foiling. So real easy, hopefully real quick. It's 10 problems. It is due tomorrow night at 11:45. And remember, tomorrow I'm not making you come to a Google Meet, and I'm not assigning anything new. So you have from now until 11:45 to just do those 10 Delta Math problems, okay? Remember, if you're coming into school tomorrow, we are in room D06, all right? And then anybody taking the PSATs, good luck. Remember, it's just a practice. Don't put too much pressure on yourselves, okay? Try to enjoy the